Hello viewers, you are welcome to this video lecture. I am here to present the 10th video lecture from chapter 3. Chapter 3 deals about the geometric design of the highway. In previous videos will be deals about the introduction about the geometric design of the highway related to the horizontal alignment, vertical alignment, and the side distance will be deals, and also will be deals about the design control and criteria. There are different design criterias. So the first is the functional classification of the roads, the terrain, design vehicles, density, and also the design traffic volume and composition is design control. Lastly, very important part will be design and control criteria will be the design speed. So the design speeds will be related to the functional classification as well as the terrain, and also deals about the highway cross-sectional elements. So many cross-sectional elements will be deals: the lane widths, the carriageway, roadway, and also will be deals about the shoulders, drainages, and also the median. It is divided the highways also will be deals, and lastly deals about the right of way. So today's will be deals about the elements of the geometric design. There are three geometric designs: side distance, horizontal alignment, as well as vertical alignment will be deals. So today's in this videos will be deals about the side distance. The alignment is composed of a variety of elements joined together to create a facility for the serve of the traffic or for pedestrians, for motorcyclists, as well as the bicycles. So this serve of those element compositions will be a safe and effective manners with align with their the facility intended functions. So each alignment should complement others to produce consistent, safe, and effective designs. There is different principal elements of the design. For example, it is a side distance, it is maybe a stopping side distance, it may be passing side distance and decision side distance, and also will be the other principal element is super elevations and the travel widths, grades, and very important is horizontal and vertical alignments are the principal elements of the geometric design. The first deals about the side distance. So side distance will be related to the driver ability to see ahead of importance in the safe and effective operation of vehicles on the highway. So this side distance is the distance visible to the drivers of the passing cars. There is two type of side distance. The first is a stopping side distance, and the second is a passing side distance. So deals about the stopping side distance when the designer maybe provide the stopping side distance of sufficient length that the driver can control the operation of the vehicles. When the driver will be see an obstacle, so the driver will be immediately stop the vehicles before striking the unexpected object. From see the objects or detecting the objects up to the stopping is the stopping side distance. And also will be the passing side distance is related a minimum of 2 lane a highway. So when we drivers will be occupy the opposite the traffic lane for passing maneuvers without the risk of an accident. There is three type of side distance. The first is side distance need for stopping. So when we drivers to see unexpected object before striking, the drivers will be stop the vehicles. So this distance is stopping side distance. And the second is the side distance need for the passing side distance. When we the vehicles will be the front vehicles will be moving at a low speed, so the back or the passing vehicles will be past the front vehicles, so there the passing vehicles use the opposite lane, so this will be and return to their own vehicle, so this will be take the passing side distance. And the third one is a criteria for measuring side distance used in the design. So this when we very important. So factors affecting the side distance will be the first is the driver response time, the baker's response times, and also will be the operating speeds and the type of obstacles are very important to factors inside distance. So we have provided the highway designers will be provide the minimum stopping side distance is very important. So the first factor is the driver response time. So first will be this is a time that taken drivers from the moment of see or detecting the object up to the drivers apply the brakes. So this will be a time to convert into the distance. Mostly many literatures will be this is the average responding time for the drivers is 1.5 up to 2 seconds at normal circumference. So most of the for the design purposes will be used 2.5. We add a factor of safety. The speeds of the vehicles is very important for the distance of side distance. When we increasing the speeds, the driver needs more stopping side distance. So the speeds will be decreased, the side distance also will be decreased. So there is the speed is very important, and also the effective braking also will be very important. So efficiency of the braking is related to the age of the vehicles and also the features of the vehicles. For example, there is passenger cars and related to the heavy vehicles, so the passenger cars will be the braking efficiency will be increased, and also the maintenance is very important. So there is mostly there is not possible to attain 100% of effective braking. So for safe the geometric design will be recommend 15% braking efficiency. And the friction between the road and the vehicle tiers is very important. So there is if the friction is very high, the stopping side distance also will be decreased. So this friction is depending on the tier uh, the tier friction or the and also will be the smoothness or the roughness of the surface road surface is very important, and also road gradients also very important. So there is a steep road gradient amplifies the vehicle's speeds. So more there is a steep, so more stopping side distance is recommended. And the stopping side distance will be deals about sufficiently long to enable a vehicle traveling at the design speed to stop before reaching stationary objects. This is stopping side distance will be divided into two distances. The first is the distance by a vehicle from the time drivers notice or detect the objects up to braking apply is the first distance. The second distance is stop vehicles when we applying the applied brake. This stopping side distance is affected by the speed of the vehicles, so increasing the vehicle speeds, the stopping side distance also will be increased. And also the efficiency of the brake, so the braking efficiency is 100%. We apply brake, so immediately will be stop, so the stopping side distance is decreasing. And also the total reaction time also very important. Longitudinal slope also very important. The frictional resistance also very important. So this stopping side distance will be divided into the braking reaction distance and the braking distance. Braking reaction time is first is the interval from drivers recognize or see the obstacle to the the drivers apply the brake. So this is the manufacturers to stop the vehicles in a short distance. So the first is the visual acuity of the drivers, and also the nature rapidly with the driver reaction, the atmosphere, the environment is very important. The type and condition of the road is also will be, it is dry or it is smooth also will be very important. The nature of the obstacles also will be very important. There is the size of the obstacle, and the vehicle speeds and the roadway environment probably influence the reaction time. So the drivers travels at near or at the design speed, it is more alert will be than one drivers will be traveling to in low speeds. Most of the braking reaction time will be using 2.5. It is at normal conditions. And also we have the reaction distance will be depending upon their the time and the speeds. So reaction time reaction distance is equal to 0.2782 times the speeds times by the time. And the braking distance will be, it is the drivers will be applied the brakes, the vehicle is not immediately slope, so there is a sliding. So this sliding will be the braking distance. So this distance will be related to the speeds. So the speed is increased, the distance will be increased, and also the friction of coefficient of friction is high, so the distance will be decreased. And also the gradient, it is uphill, the distance will be decreased. It is downward, so the braking distance will be increased. So the stopping side minimum stopping side distance is determined by combination of two formulas. The first is reaction distance plus the braking distance. So minimum stopping side distance is equal to 0.2782 times the speed times the time plus v square over 254 fraction plus or minus the grade. So era manuals will be placing the already will be the design speeds, the reaction time, braking distance, also will be calculate the stopping side distance. So for example, the vehicles will be moving in 20 km per hour, the reaction distance will be 13.9. The braking distance will be after apply brakes, the vehicles will be moves 4.6. So this it is the calculating stopping side distance will be 18.5, so the design will be add some safety of factor distances, so we have around will be 20, for example 31.2 will be use 35. And the second side distance is passing side distance. This distance is a minimum side distance is on minimum of two-way single roadway, so available to enable a drivers of one vehicle to pass another vehicle safely without interfering with the speeds on the coming vehicles. So this one is the passing side distance will be should be see a sufficient distance headers clear of the traffic without cutting off the passing vehicles before meeting at opposite vehicles. This passing side distance, there is assumptions concerning with the driver behavior. The first one is the taken vehicles traveling at a uniform speeds, and the other is the passing vehicles have reduced speeds and overtaken vehicles as entering the passing section. So, and also will be assume that the passing section is reach, the passing driver needs a short period of time from perception to a reaction. And the passing vehicles also will be passing a minimum of 15 kilometer per hour greater than the overtaken vehicles. For example, the overtaken vehicles will be moving at 15 kilometer per hour. The passing vehicles is a minimum of 16 plus 15, it is 75 kilometer per hour will be a minimum speed. When it is a passing vehicle returning into the lane, it is a suitable clear length between the ongoing and the passing vehicles. Mostly 13 up to 17 meters will be required. So this as shown on the figures. This one is passing vehicle, this is overturning vehicle. So the passing vehicles will be before take opposite lane, there is perception and reaction. So perceive and decide, we are going to this, so there is no return to their vehicle. The ongoing vehicle will be reaches, so not out from this on lane. So there is the vehicles will be moving in this, so the vehicles will be moving at uniform speed. So this vehicles is greater than a minimum of 15 kilometer per hour related to the overtaken vehicle. So moving use the opposite lane and return to their own vehicles. So the ongoing vehicles will be coming from this up to this. So the first is the first four distances. The first distance is the vehicles from the current condition to the perception reaction, or out from left from their own lanes. So this distance will be d1. So the d2 is from out up to the opposite lanes will be at d2, and and also will be the d3 will be the clearance between the passing and the coming vehicles, and d4 will be the distance from the ongoing vehicles from this condition and up to this, it is d4. And d1 will be the perception reaction acceleration distance. It is not hard to understand or justify, so this distance will be gate will be d1 is equal to 0.2782 times the time and speed minus the difference speed between the pass vehicles and the passed vehicles. So a minimum of 15 kilometer per hour. Acceleration times the time over 2 will be d1. d2 is distance during the passing vehicles in opposite lane. We have these distances from out to uh, almost use the opposite lanes will be d2, so d2 is equal to 0.2782 times t2 is the time passing on the opposite lane. d3 is the clearance between the passing and opposite lanes. Mostly it is very important parts, so mostly will be used 13 up to 17 meters depending on the speeds of the vehicles. d4 is the distance traveled by the opposing vehicles, so from the previous condition up to now, when the vehicles will be left the opposite distance, so there is a distance, so d4 is mostly related to the ongoing vehicles. So the total minimum passing side distance is equal to the sum of all distances. From this up to this is d1, so from this up to this part is d2, from this up to this part is d3, so from this coming up to this part will be d4. So and similar to stopping side distance, era manual also will be placing for passing side distance. So the design speeds will be 13 kilometer per hour. Taken vehicles will be moving, or the front vehicles will be 11 kilometer per hour. The passing vehicles will be a minimum of 5 or 15 kilometer per hour, so we have 13 kilometer per hour, so minimum passing side distance is 120 meters. And the last part is side distance measuring criteria. Side distance is the distance along the roadway throughout an obstacle objects of a specified height is continue visible to the drivers. So this stopping side distance should be checked during the design, and adjust should be made to meet the minimum requirements. The following values will be very used to determine the side distance, minimum side distance. For example, a driver heights will be assumed as passenger cars use 1.07 meters. For trucks will be the height will be increased 2.4 meters, and also for stopping side distance the object height will be 0.15 meter or 15 centimeter, and for passing side distance we'll use 1.3 meters. So for a stopping side distance, the coming vehicles will be, the height will be passenger car, there is 1.07 meters, and for trucks will be 2 meters. The objects will be stopping will be distance is 0.15 or 15 centimeters, so vehicles will be say at these objects when we reach this. So these vehicles will be immediately stop, so there is from this up to this is a stopping side distance. For passing side distance will be, the vehicles will be these vehicles will be pass this vehicle, so the coming vehicles will 1.3 meters. So when we from this from the passing, there is passing side distance. And also will be say on horizontal curve, that will be a vertical curve. In horizontal curve, when we the vehicles will be coming from these directions and will be entering to the horizontal curve, so there is a vehicles will be in there, so we have see the object is coming from this direction, as well as a stationary object, so there is a suitable sight distance. So these parts will be, M part will be a clearing zone. So there is no construct a buildings or not green in this part. So we have very important for a vehicles will be see this immediately stops. So thank you for listening my video.